Hello, this is MEI Further Maths Core Pure. We're in the first complex numbers section and on the fourth video on dividing complex numbers. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. Pause the video now and expand these brackets. What do you notice? Hopefully you spotted that this was a difference of two squares. So we get 25 take away 4i squared. That's the same as 25 plus 4, which is 29. So we get a real answer from this complex expression. This is typical of using the difference of two squares, and it's a technique you'll already have met at GCSE when rationalising SEDs. This is very similar, but note of course that we get the sign change from the I squared, and we always get a real answer. The two numbers 5 plus 2i and 5 minus 2i are known as complex conjugates. When you multiply them together, you always get a real number. So, dividing complex numbers is just like rationalising the denominator with SEDs. You could call it realising the denominator, though nobody does. We want to make the denominator just a real number. We can do that by multiplying it by I, so that we get 3 plus 2i all over I is equal to, multiplying the denominator by I, we get I squared, and then we need to do the same to the numerator. Multiplying out and simplifying, we get 3i plus 2i squared all over minus 1. That's 3i minus 2 over minus 1, which is minus 3i plus 2. And normally we write the real number first, so that's 2 minus 3i. Here's a more complex example. Again, we want to make the denominator real. We can do that by multiplying by the complex conjugate, and then we need to do the same to the numerator. So we start with 4 plus I over 2 plus 3i, and we multiply numerator and denominator by the complex conjugate of the denominator. That's 2 minus 3i. Pause the video for a moment while you complete this by simplifying. Okay, what you get is 8 minus 12i plus 2i minus 3i squared all over difference of two squares 4 minus 9i squared. Simplifying the top, we get 8 minus 10i plus 3, and the denominator is 4 plus 9. So that gives us 11 minus 10i over 13. It's usual to write this as two separate numbers, so 11 thirteenths minus 10 thirteenths I. So in summary, to divide complex numbers, you write them as a fraction, and then you multiply the numerator and the denominator by the conjugate of the denominator. Then you simplify it and write it in the usual form, a plus or minus bi. There are more notes on integral on dividing complex numbers. That's the end of this short video. The next video in this series is on terminology.